Hi, I'm Andrew. Today I would like to teach you how to find the end behavior of the given function f of x is equal to x to the fifth over 10 minus x to the fourth by using a table method. All right. Now, there's many ways to solve this particular problem. You don't need a table to do this. You could do it algebraically. You can do it thinking about limits. There's a whole bunch of ways to do it. If you want alternative methods, I'll leave a link in the description below for some other videos I've done on the same topic but using a different tool. So first thing is, why don't we create a table? Now we can create the table, all right, by using our calculator, but we don't really need the calculator to do it. But I'm going to do it just to save time. So go to your y equals, okay, and you're going to hit x to the fifth, x raised to the fifth, and then go divided by 10, okay, then hit minus x to the fourth, so x raised to the fourth. And then what you can do is hit second table, and you're going to get a table readout. Okay. Now, if your table might not look identical to mine with the steps, but what you can do is you can do second window. That'll bring you to your table set. Start the table at 0, so just hit 0. Then go down and increment your table by 10 units. You don't have to. You could do 5. You could do 1. You could do, whatever number you like. But I think 10 will be reasonable. Then go back to your table, and it should look just like this now. And what I'm going to do is I'm going to put 0 in the middle, somewhere around there. All right, to help me analyze the problem. So now let's take this and let's take a look at the numbers, okay? So what we realize now, and this table, by the way, is created by the following. If you were to plug 0 in for x, okay, so if you literally take 0 and you plug it in here and you plug it in here, what should the value of this function be? It should be 0, right? And that's exactly what this says. It's going to be 0. Okay, so that's all you would need to do then to create the table. You just take some numbers. So let's say negative 10. If you plug negative 10 in for x up there, negative 10 in for x over there, the function's value, the whole thing will become negative 20,000. And that's all you would do. You would just keep plugging in these x's, all right, keep solving this equation on out. As you can see how long that would take. But that's how you would do it, all right? So, but now that we have this table created for us, what happens as x moves larger and larger in the negative x direction? Well, y moves larger and larger. It gets larger and larger in the negative y direction. Yes? So how do we say that mathematically? Well, we say that as x becomes larger and larger in the negative direction, meaning as it goes to negative infinity, the y value, or aka the f of x value of the function, will become larger and larger and larger, but in the negative direction. Okay, that's how we say it mathematically. So that's what it would be. And then as we go out in the positive x direction, as x becomes larger and larger and larger in the positive direction, what's happening to the general trend of our y value? It's becoming bigger and bigger and bigger, right, in the positive direction. So as x goes to positive infinity, then the function's value will go to positive infinity as well. And this would be the end behavior of the graph, all right? What they mean by end behavior, just so we're clear, is what happens at the fringes. What happens when x becomes really large in the negative direction? What happens as x becomes really large in the positive direction? And this is basically what will happen, okay? So that's all there is to it, all right? You don't need a table to do this. You could do this algebraically. There's so many ways to do it, all right? Check out the link in the description below. And I look forward to helping you with more problems. Have a great day.